Hi everyone, in this video I'd like to introduce on how to define a procedure in the Mathematica. It's very useful. It's more than just defining a function. You might find my video of defining a function in Mathematica. It's kind of the same procedural, but the structure of the definition is more involved. So here it is. I will use this example to go through. So here's a task. Given a function, we have a function and an interval. Then we're going to sketch the graph of the function and graph of the tangent line at the midpoint of these 2 points there. So this is if I give you a specific example of f of x and interval, and here's how you're going to do this task in the Mathematica. First, you're going to define f of x like this. This is how you define a mathematical function in Mathematica using this underscore and colon equal symbol. Since we're going to be using this interval many times, we're going to actually call this 2 and 3. That's a part of an example. Interval 2 and 3 is what we're looking at. So we're going to call A2 and B3. And you probably want to see how the graph looks like, so we sketch it using this plot command, graphing the function f of x on the interval x going from A to B. So next time, when you change this interval to 3 to 5, all you have to do is to change that 3 and that to 5 and execute it. Everything that has a, b in the following part will automatically fix it, so you don't have to fix over and over again. Now this part is for the midpoint, because the problem asks us to compute the midpoint. So look at the left-hand and right-hand point and divide it by 2. That's exactly the x-coordinate of the midpoint there. And since we want to compute the tangent line, we want the slope, and slope is the value of the derivative, so you calculate f prime of c value there. And a computer gives you this value. Then you probably want to call it, okay, that's going to be my slope of the tangent line, m equals f prime of c, and that's going to represent that. Instead of copying and paste, this is how you're going to do it. And tangent line as a function is defined like this: y-coordinate plus slope times x minus c. That's where the x-coordinate of the tangent line is defined. So that's going to be your tangent line. And we want to plot the original function and tangent line together. And here's a nice picture of that tangent line. So this is the entire task, right? So I made it a little bit smaller to show you and how we broke this into a smaller task. We sketched the graph, defined some of the things, and down there we calculated the c value and the slope. And the third step, we try to sketch everything together. Now if you want to do everything at once, this is probably how you want to do this. So you don't have to break it into several pieces. If you know how things are going, you can, since after you run it, you can put it into one computation cell like this, such that everything runs in a one shift-enter key. So function is defined, a and b, the left and right point of the interval. Then we calculate the midpoint, and at that midpoint we calculate the slope of the tangent line using the value of the derivative. And next step, we define the tangent line and plot them together. So when you run this, shift enter anywhere in this cell, it's going to run in the sequence from the first line to the last line all at once, and then it's going to give us this result. So what we mean by a procedure is that we're going to program this procedure into one command. So we define this whole thing called whatever the name, sketch a tangent line, and if I give you give the Mathematica information, the function, and these two numbers, then it automatically does all that thing at once. So that's a procedure, and I'm about to show you how to do that. So what we're going to do is put everything in here into one command. So the following is called a global parameter. The function that we're putting into, and this left-hand and right-hand point of this interval, those are global information. But they're intermediate thing that we're calculating here to produce the result, and then we throw this away in the result. So c, m, And this TL, these are the thing that we use as an intermediate part. We use that to show the last result, and this is the only thing we want to show. So those variables that are used here just to get the answers, but not as global, we call them local variables. So knowing the global and local variables in this sense is important to make the procedure correct and not running into any errors. So here's how you do it. I'm going to call that procedure sketch tangent line. What input is the name of the function f and the interval in the bracket form. So this one has a and b in it. And this is a typical way of defining things, equal, and enter, not shift enter, so it goes to the next line. And this is important structure, the one structure you need to get used to. This called as module. It allows us to define a local variable. Right now in the global variable, there's no a and b. So a and b will be the left end and right end point of this interval. So we call that as local here, and c will be the midpoint. So that's also a local variable. And m is the slope, and TL is the name of the tangent line. So these are just intermediate things that we're going to use to produce the final result. So this is a mere copy of what we did, and what goes into this part here is in this form, bracket 2 and bracket 3. So interval goes in there, and in this module part, in this procedure, we're going to take that like this, and then it defines a equals whatever the first component in here, b equals whatever in the second component. So a equals 2 and b equals 3, all done in one command like this. And c is going to be the midpoint. M is going to be the value of a derivative, the slope. And we're defining TL as a function, tangent line in here. And after that, we're showing the last result. That this is last result, last thing, the returning result in this procedure does not have this semicolon. If you have a semicolon and we will do this procedure and not showing anything, we do that. Mathematica does this part, not showing anything. Mathematica does this part, not showing anything at the end. It shows whatever it is asking us to show. Plot the original function and the tangent line over this interval. And this bracket here goes with this module bracket at the beginning here. All right? So that bracket thing is a little bit confusing in the Mathematica, but you have to count them correctly. So again, module is the command that allows us to define a local variable. So they are only used in here in the procedure and thrown away. It only shows the result. So when you combine many procedures inside the procedure and inside the procedure, using the module, it's important so that Mathematica is not get confused by C that used here, not get confused with the other C that was used in a different procedure. If it is defined properly like this, and there's no confusion, everything runs smoothly. Now once you execute this command like this, then you can experiment. Okay, I'm going to look at different function, x divided by x squared plus x plus 1. That's my new function I defined here. And I'd like to sketch the tangent line in between 1 and 3. So this is how the interval is put in, and that's what we mean by that interval, and as a local variable input it this way. So interval goes like this, 1 to 3. And just the name of the function, not gx or expression like that, just the name of the function and goes in there. Then it's going to repeat all that, and then it's going to show this result, the plot of the graph and the tangent line. So when I ran that, it shows us this point between 0 and 1 and 3, and right in the middle point, it's there. So let me try some other point. So I'm trying this -1 and 2, and I'm about to hit the shift enter and see what Mathematica shows. It shows that, okay, between -1 and 2, graph looks like this. It shows the right in the middle point and sketch the graph of the tangent line. So this is very, very useful for many things. But make sure that you declare local variables correctly and use it. You can call this procedure inside the procedure, inside the different procedure. When you do that, declaring all the local variable is important.